Okay.
Okay.
Hello, everyone. Thank you for joining for today's MyCaptain Power Talks on how companies are using big data analysis based on case study. MyCaptain Power Talks is powered by Qfuss. Qfuss provides an interactive cloud-based on-demand mentorship platform and acts as a one-stop hassle-free solution to have conversations with industry leaders. Qfuss offers a complete set of tools such as hosting skills, knowledge-based workshops, and coaching to enhance the skills of individuals. It is more of a safe space outside your office or public space where you get the insights from leaders who have traveled the same path that you're about to take. Our guest today is Salil Trehan. It gives me immense pleasure to welcome and host the session with a passionate data scientist at Nielsen. In addition, forecasting, geospatial, and clustering analysis specialist, data science evangelist. He has made tremendous success in his field of data science, one who possesses a natural love towards mathematics and innovation. One thing that spots our eye is your affinity towards people, being supportive enough to teach and learn new things, which is equally inspiring to us, sir. We are glad to have you with us with your amazing skills and interest in the field of data science management, data modeling, predictive modeling, data visualization, statistics, and the list goes on and on. So, by not wasting our time, let's move on with the session and handing over to you, sir.
Okay. So first of all, I hope you all guys can hear me properly. There's no there's no problem with the voice, so that we can have a beautiful session today. Just wanted some yup and maybe yes, if you can all, if you all can hear me, the chat. Okay. Okay. Cool. So I will present my screen. If, okay, you have to give me the permission to present my screen.
Yes, sir, one second.
So in the meanwhile, just when she's giving me the permission, uh, I'll just like she has already set the bar up for me. So I just want to bring the bar a bit low. So I am just another student, just like you all guys. 1 year
So I
back,
have
I was
given you the permission. So
yeah,
excuse.
yeah, I see
Yes.
that. I see
Okay.
that. I see that. So even I was just a student like you. I finished my MBA, then I did my course on data science, and I joined Nielsen 1 year back in February 2020, just when the pandemic was starting. So one month I went on the office. From the next month I was working from home. Uh, so that's mostly about me. So there are many things which she has said. I've worked on all those things. Everything is true, but I'm just another student like you. Even I'm learning. I'm learning as the time goes. So feel free to ask me any questions. And I have just thought one thing in my mind that most of you are coming from a like don't come from a hardcore data science background. So I just kept the whole presentation very basic. So there might be a lot of questions that might come in your mind. I'd like you to come up with those questions at the end, so that I can maybe help through that. What would be the best way to answer that question? Because not all questions would be I would be able to answer it over here, because since the topic is very vast, and I'm going to cover a very basic portion of it. So, but yeah, I'll definitely help you out on where you have to go, what you have to read up, and how you can explore more about the field, and if you're interested in around it. So I will start sharing my screen. I hope everyone's fine with the dialogue which I have shared with you. And yeah, I will not be able to, see what you guys are writing in chat. So maybe if there is something very urgent, so maybe you can
Uh,
interrupt me.
so one
Yeah.
second. I'll make sure that we take the questions in the end.
Okay. Cool.
I'll let them know that to type in Q&A section the questions. Okay.
Okay. Cool.
Yes, sir. Thank you.
So I hope you guys can see the screen. I hope everybody can see the screen.
We
Okay.
can, sir.
Okay. Cool. So yeah, so big data analytics, like what's big data analytics? Like I'd start with some a few questions like what comes in your mind when we talk about big data analytics? Like is it something related to huge chunks of data? What is analytics? Like whatever thing comes in your mind, just let me know that what do you understand by big data analytics? Have you ever heard the term? Have you ever heard its application? Like uh, have you heard anything, absolutely anything about it? Just type in the chat and maybe let me know that what you all guys know about it. I'm just looking into the chat. Okay, okay. We don't have much idea. Okay, no issues, Ashita. We'll explore about it today. Anybody has ever heard about it? What is the application of these things and what we can do through it? How our business is using it these days? Something related to coding. Interesting. Okay, analyzing large sets of data. Very, very, very close to it. So the name is self-explanatory, but yeah, Vineet is very close to it. Anybody else? Whether Vineet or I think that's it. So anyway, Weber and Vineet, yeah, you are right. Weber is related to coding, and yeah, it's through coding we are analyzing large is dealing with GBT. Okay, yeah, yeah, huge sets of data. That's correct, absolutely correct. So yeah, so what we're doing, we're using coding to analyze large sets of data, and the data is of the size GB, TB, gigabytes, terabyte, like something like that. So let's explore a bit more around it. Uh, yeah. So before starting this, and I'll just like okay, I have you guys had an introduction about myself. I'll skip the slide. Okay, what does this kind of job give to the business? Like Jeffrey Moore is a, American organizational theorist. What he has to say is that without big data analytics, companies are blind and deaf, wandering around onto the web like a deer in the freeway, because they don't know what to do with the like. In today's days, you all know that there's huge chunks of data. Like if you talk about big organizations like Amazon, Netflix, these all guys have huge chunks of data. All FMCG companies like Colgate and all, they have huge chunks of sales data and at a all all over world level. So obviously through that data they are analyzing these days what should be the best way to come up with a marketing strategy, what should be the best product they should come up with, and what should be their target areas. So these are certain things which they're exploring these days, right? That's what experts have to say about this job. Now let's see a simple big data life cycle. Now, if we talk about life cycle, is like how do we do big data analytics? So, just after seeing this whole section, my first reaction to the this whole thing was like this. So you talk about big data analytics, people love you, right? But if you talk about big data, everybody's losing their mind. We don't understand what big data means. Like data analytics is simple. We have some data, we do some analytics, we just generate some insights out of it, and we're saying that we can do this, we can do that. But when it comes to big data, many people in the industry don't know how to deal with it because many of the softwares are not made in such a way that they are working on very huge amount of data, like in the field of terabytes or something like that. So that was my reaction. And if you have the same reaction after looking at this, so you are pretty much at we both are at the same page, right? So moving on to the next slide. So let's try to make this simple, right? Uh, let me break this down into very simple steps and try to explain this to you. Okay. Uh, so there are three V's of big data, right? Volume, velocity, and variety. So what does volume mean? Volume, obviously, as everybody mentioned, that it's we have huge chunks of volume. Like the data has a very low density. Mostly the data is unstructured. Like suppose I'm trying to do some analysis on Twitter data, right? Uh, now, what is Twitter data? आप जो ट्वीट कर रहे हो वो जो ट्वीट है that is a data to the company like Twitter, right? Now that doesn't have any numbers, right? वो तो text है, right? So what does company do it? They try to convert that. So that's basically unstructured data. Okay. So what the companies are doing is they're trying to convert that unstructured data into the data which is helpful for their engines to work around it, right? कि उसके थ्रू कुछ actionable insight निकाल सके. जैसे for example in Twitter data mostly what they do is there's a very common term called sentimental analysis, right? They just try to understand कि okay, suppose if we talk about Bitcoin, आपने सुना होगा that Elon Musk ने ट्वीट किया and तुरंत बिटकॉइन का प्राइस ऊपर उठ गया, right? So such type of tweets affect the user sentiments, and through that the markets get affected, like the Bitcoin market, the stock market. So just trying to do a basic sentiment analysis will help you, right? So volume plays a very big role. Then velocity plays another a very big role again. Now suppose आप आपने कोई application खोला. Now these days if you talk about Amazon, right? आपने कोई Amazon में कोई video पे click किया, you just click the video and it is taking around 5 minutes to open up. So will you use it? Will you use the application? Obviously no, right? So if you want to have like people use your application, you want to have speed with it attached to it. So what all data you're receiving from the user, what all data you're transmitting back, that should be very fast. So velocity again plays a very big role in when you talk about big data, right? Then comes variety. Now there are many types of if you're talking about big data, there's not just one source which you're talking about. There are multiple sources from which you're procuring data and doing the analysis, right? So again, you have to make the whole system in such a way that the variety is taken care of. Now variety can be a textual format like Twitter data, an audio format like, for example, you have Ghana.com, right? So all of its products which it's selling basically to you is songs, right? So in that case it will be audio data. In case of Netflix it will be video data, right? Then the list go on and on, right? So these are the three major things which we'll be focusing on when we're talking about big data. So moving on to the next slide. Now how does big data work? Like big data we use to generate new insights, right? We the businesses get new opportunities. They How do they get new opportunities? They are able to but as the time changes, the requirement changes, they are able to build in different types of business models. Like suppose there was a time when there was no internet, right? So the business models at that time for maybe Colgate would have been much different. Maybe it would have focused more on TV advertisement, right? But in these days, the business model is through online medium and offline medium as well. Like TV advertisement is always there, but through online medium also they're doing that a lot of advertisement. And the advertisement can be of different types. Maybe they're doing some event to promote, or maybe they're coming up with the product, or maybe some offers. So totally depends on the business and what the viability of the business is. So how do they do is there are three key points of action. So as I told you that we integrate the data. How do we integrate the data? We are basically extracting it from different sources, and then we are transforming it into a certain format. Then we are loading it into our system, right? Where we will be using it to do the analysis, right? Now, obviously, the size of the data is very big. If you just talk about data analytics, then just two steps would have been there. One would have been one would have been integrate, one would have been analyze. But there is a manage step which comes in between when we talk about big data analytics, right? Why is this manage step coming over here? Because the data size is too large. So you need a management system. Like suppose if you're talking about a school, if a school has just 5 students, then a simple teacher can suffice. You don't need a management system for that, right? But if the school size multiplies to 500 students, and you need proper list of teachers, proper management, and everybody to take care of the whole school, right? So similarly, in this case, if you move from data analytics to big data analytics, the whole system requires a management system. And that management system is like AWS these days and Azure Databricks. Azure is basically Microsoft product, and AWS is an Amazon product. So these type of data management systems, cloud data management systems, are actually helping out various businesses to generate actionable insights these days through the analysis which they're doing on the cloud itself. They're not doing any it on the systems anymore. Everything is on the cloud these days, right? So again, this is another very big thing for the businesses, and this is a skill which will help you in the long run. So moving on to the next slide. Mostly, if you talk about the basics of big data analytics, this was all about big data analytics. Now I'll come to my case study where I'll be talking about Amazon. Uh, I'll call Amazon the mastermind of brain reading. I'll tell you why. So what Amazon has done, like if we talk about the business use case, so what it has created a recommendation engine. Now a recommendation engine seems self-explanatory. What it is doing, it's basically recommending certain products to various users, right? Users care. For example, if we talk about daily location, okay, daily people might have different types of users. Some people are rich, some people are not so rich, some people are like lower middle class or something like that. So there are various kinds of people. They have various types of choices, and if we talk about all those things, processing it all on your system, on just your system, is not something which is viable, right? So again, for this particular use case, what Amazon has done, it's uh, use big data analytics to develop this recommendation engine. Now, what is the recommendation engine? So I'll talk a bit about recommendation engine. I'll get a bit around the theory and nitty-gritties of recommendation engine so that you can understand what Amazon is doing and how it is building a very good solution for the customers. Obviously, this is a solution which is under development. They're continuously building and improving it. I have at the very end, I have mentioned certain research papers which everybody can go through and explore more about the process which they're going through. But I'm just going to give you a brief overview of what they're doing these days, right? So, in terms of recommendation engine, they're coming up with the new products. They're upselling, cross-selling, and they're doing a lot of product discovery. So I'll talk about upselling and cross-selling in the next slide, but I think the rest two terms are understandable. They are coming with new products like basis demand in a particular area. Let's suppose if we talk about northeastern states, it's prone to a lot of rain, right? So and if you talk about northeastern region, there's a very there's a very common habit of those people. It's basically non-veg eating habits. So there can be various type of innovative products they can come up in terms of non-veg eating habits. So catering to the non-veg eating habits. So maybe packed food, something like that, which is not obviously accessible in those regions. So such type of new product discovery they are doing, new products they are introducing. They're doing a lot of product discovery. Like certain regions have certain affinity towards certain type of products. They're doing that product discovery. I'll talk about these two terms. Now, what does these recommendation engines do? They're helping the businesses understand user preferences, their intent, like what do they want to buy, what do they like, what are their characteristics. So it's very beautiful. They're getting this just through certain clicks. Like you're doing a single click, and they're learning a lot about you. Like what is your characteristic? What do you want? What is that you would like to buy next, right? So I'll share some examples also. You must have seen those things on the Amazon website also. But first I'll explain upselling and cross-selling. So what is upselling? Now, suppose you are buying a mobile phone, right? Obviously, when you buy a mobile phone, you obviously need a screen guard and a back cover and all these things. So they recommend you those things in the bottom, and they say that if you buy this and that, and you will get a discounted price of on the overall package. So that would be upselling. Just selling similarly related products, uh, uh, not related products actually, complementary products, which are normally bought along with those things, right? So that would be upselling. If you talk about cross selling, so let's suppose you went to buy some furniture, right? You're just going out to buy a table for your bedroom, right? Instead, you buy the whole set of items in the bedroom through Amazon. So that would be cross selling, right? In this case, we have just said that if you're buying a mobile phone, it's going to recommend you a headphone also along with it. So high price items which are sold as a pack. So it's very similar to upselling, but yeah, there is a certain difference that these are not really, certain items which are usually bought together, right? So, but they are related to each other usually. So yeah, this is product both. This is upselling and cross selling. Uh, and guys, I know that certain terms can be heavy, so but I would just want you not to remember those terms, but just try to understand what Amazon is actually doing through these recommendation engines, right? So moving on to the next slide. Now, as I told you, I'll share some examples. So you must have seen certain examples like this. So you went on to buy this book. It's called Elements of Statistical Learning, and you got recommendation to buy these two books also in the bottom. And they're saying that in this much price only you will get all these books, and this was the respective price. So you give a discounted price. This it's saying that they are frequently bought together, uh, and there it's also giving you other items like customers also bought these things along with this particular book. So this you can select any one of them and you can buy it along with it. So these are certain like examples of recommendation. Another example I'll share with you. So over here you can see you just explore this introduction to data mining book, and so see, I'm giving a lot of examples of books because we are here to understand about data analytics. So I've just picked out those books which are actually helpful for data analytics, so that you can also that can also be helpful for you. I don't need to ask me the books, right? So so we just saw this. Try to buy this book, Introduction to Data Mining. So it's showing me what other customers have bought along with this. They have been doing certain, they've been exploring these things also, so you can buy this also. So these are certain examples of recommendations which Amazon is doing, right? Now what are like what is a good recommendation engine, what are the challenges? Let's discuss about it, right? So if you talk about a good recommendation system, so if suppose you're a programmer, like I would not call myself as a hardcore programmer, but okay, let's suppose I'm a programmer. So I would get programming books when I'm exploring the book section of Amazon, right? And if suppose there's a mother who is exploring certain items on Amazon, so she gets like in terms of recommendations, she gets baby toys because she's prone to buy those things, right? So that would be a good recommendation engine. And a good recommendation will be something which uh, doesn't recommend the users which they already know, certain items which they already know and would find anyway. Like there are very common items which we buy anyway, like suppose atta and all those things, brush, toothpaste. These things are like something which we already buy. So recommending those things won't actually help the revenue. So anyway you will buy na, on a monthly basis. So that is a constant revenue, but there are other things which you don't really buy and a regular interval like mobile phone, laptops, table or AC or something. So these type of things would be recommended on Amazon. Uh, so uh, suppose so the next thing it's saying that if it expands the user taste without offending or annoying anyone, like suppose a person likes a lot of horror movies. He also likes a lot of superhero movies, action movies. So let's suppose the recommendation engine is just giving him one movie, which is Avengers Endgame. All the time it's recommending the same movie, so any user will start getting annoyed. So it should not, just give the same recommendations all the time. It should have some variety along with it. So that would be a good recommendation engine for me. So now, if you talk about the challenges, now obviously the biggest challenge when you talk about big data analytics is the word big, right? The big means that there are huge amounts of data. There are tens of millions of rows of customers. There are tens of millions of data of items, which you have to recommend to the customer. So it's becomes very hard. Who should we recommend what? Like what customer should be recommended which type of product with, like in case of Netflix, that would be a movie. So which user should be recommended what type of movie? It becomes very hard for recommendation system to do that, right? And obviously results have to be returned in real time. So obviously, as I talked earlier on, the system should be very fast. It should be like, it should not take more than 1 second to return back the recommendations. So it should be fast. Then it should not be just like, it should give certain amount of information to the new customers also, because when a new customer comes, there is no data for him, like what are his likes, what are his dislikes. So there should be some limited amount of information recommended to him also, versus certain characteristics which is capturing. Like for example, if you are a new user, you're signing up on the Amazon website, then you give your name, you give your gender, you give uh, your basic consumer demographics, like where you are from, all those details, right? With your pin code. So basis that, it gives you certain recommendations. So that should also be there. Uh, all the old, as I mentioned, the old customer should not be seeing the same type of recommendation again and again, because it becomes annoying, right? And obviously customer data is very volatile, so again security concerns is also there. So we have to take care of this also when you're talking about big data analytics, right? So moving on to the next slide. uh, what is Amazon's solution to all this, right? What has Amazon done to cater to these problems? So what has Amazon done? It has basically recommended a recommendation algorithm, which is basically designed to personalize the online store for each and every customer, right? Because if you go out on a, like in an offline retail store, and if you get a personalized assistant guiding you through, okay, you can buy this, you can buy that, you can, that would be a very bliss of an experience for you, right? So that's what Amazon has managed to do through this recommendation engine algorithm. Now what does the algorithm do? With you don't need to get into the intricacies of it right now, but just a basic understanding of it is necessary, I think. So I'll talk about it also. So in this algorithm, it is okay. Let's talk about most algorithms. So when we talk about most algorithms, what they do is they find similar sets of customers who have purchased certain rated items, and there is certain overlap in terms of user purchases or ratings. So in that case, it is going to recommend certain set of items to you, right? But in case of Amazon's algorithm, what it has used, it's used the item collaborative filter technique. What it does is, so I'll just explain it to you. Forget the term. It seems very complicated. So forget the term. So just try to understand what it does is. So it is trying to recommend similar items instead of similar customers. So as I mentioned in the previous example, what it was recommending was, if you're buying that particular book, it is again looking for similar kinds of books, right? Like okay, let's suppose you come from electrical background, and because I'm from electrical background, uh, you are buying a book on processing, digital signal processing, and so the algorithm understands that you come from a somewhat a electrical background, and it recommends you other electrical engineering books as well. If you come from a mechanical background, it will recommend you other mechanical engineering books as well. So it understands what are the similar types of items with respect to the item which you're choosing, right? And then it's recommending. So that's how Amazon's algorithm is working broadly. This is a very basic glimpse of what Amazon is doing, not the exact thing, obviously. For that, you have to read into what all research papers they've published. So yeah, that's basically the Amazon solution. Then there are various types of recommendation engines. It can be a content-based engine. It's either focused on user, it's either focused on items. The similarity between items, like suppose if it's a horror movie, how what is the duration of it? What like there are various characteristics of a movie. So it will either be focused on those characteristics or it will be focused on user characteristics like user demographics. That would be content-based method, right? And to talk about collaborative filtering, in this you are exploring both the things. You are basically so one thing which is common in both the techniques, model based and memory based, is a user item interaction. So over here it was either your user, right, or an item. My bad, I have a very bad handwriting. So I hope you guys understand what I'm saying more than what I'm writing, right? So this is item. Seems like stem. I'll make it item. Okay, user and item. So either it was focusing on user, either it was focusing on item, right? But in case of collaborative filtering, it's focusing on the interaction between user and item. Like suppose if you talk about the interaction part, so it will either look at the purchases or it will look at your likes and dislikes, like what rating you are giving, what type of comments you are passing. So this is basically the interaction. So basis of that interaction, it is going to develop the recommendations and give you the output. Now then there is a hybrid technique also. So in hybrid techniques, like obviously collaborative filtering is a much better way as compared to content-based methods. But when there is no data of any user, like the user is totally new to your system, at that time you will try to use a hybrid model, wherein when a new user comes in, it will switch to content-based methods, and when a user becomes old, then it will switch to collaborative filtering-based methods. So these are certain types of recommendation engines. Then moving on to the next slide. Okay, so I've already explained this, but yeah, okay, I'll explain it anyway. So in this example, one is user-based filtering, where and another is item-based filtering, right? So both of these examples are using an user item interaction over here. So suppose this particular person is liking all these things. If she's liking grapes also, she's liking this strawberry also, she's liking watermelon also, she's liking orange also, right? Uh, and if this particular user is similar to this one, like for whom we have to do the recommendations, and we saw that this particular user has chosen this one, this item, and this one, he has rated these two items highly. So what the user based filtering method does, so it is going to recommend the other two items like by the similarity, like these two customers are similar, so the other two items like by this customer is being recommended to your this first customer, right? So that's what user-based filtering is doing, and item-based filtering is doing the exact opposite thing. Suppose these two items are similar to each other, right? And suppose this person has spoken very highly about this particular item and this particular item, and this particular person is speaking very highly about this particular item, so he gets recommended this particular item because this person because this item was similar to this. So this the user gets recommendation of this particular item as a recommendation. So this is what item based collaborative filtering works like. Amazon uses this particular technique. This is what Amazon is using these days instead of this, because obviously there's a limit to your user data which you can define, but there's no limit to item data, right? So that's why Amazon chooses this technique. Okay, so why do like we have explored so many things about recommendation engines, but why are they necessary? So first thing, as I mentioned, if you get a personalized assistant when you go to retail stores, right, that would be a bliss for you, right? You're getting recommendations of what you should buy, what you should not buy, what you should focus. Instead of wasting all that time on all the items, you're just focusing on very specific items which are actually relevant to you. So in that way, you are increasing the number of items that are sold. Okay, you're selling more set of diverse items because the certain related items to that, like in case of mobile phone, like it's shared, the mobile case is also related, the headphones are also related. So you're selling a diverse set of items, both on a low cost basis and on a higher cost basis, right? So you are able to do your business in a much efficient way, and obviously the user satisfaction is increased, right? Because it's a personal assistant, right? Then the recommendation helps the businesses understand what the user wants. So it's just saving both the business's time and the user's time. So that's helping into us, right? So that these are certain things which help in terms of recommendation engines. Okay, so coming back to big data analytics, we have explored a lot about recommendation engines, and I hope you guys are okay. Let's checking the inbox. Let's see the inbox. Okay. So coming back to this big data analytics life cycle. So we've talked about big data analytics, like in very simple words. We've talked about recommendation engines, like that's the algorithm which uh, Amazon is using at the backend. But let's try to understand this big data analytics life cycle after we have done all this uh, understanding all these things. We should try to understand this life cycle. So I'll try to understand, make you understand in a very step-by-step manner. So let's go ahead with it. So yeah, okay. Next slide. Yeah. So over here, as you can see, there are various data sources coming. Like you can see from mobile communication networks, some data is coming. From vehicular networks, some data is coming. Mobile social networks, there's some data coming. IoT, smart home services. So just assume, like, don't get into the technical terms from where the data is coming. Just assume that there are multiple sources of data which are coming to your business, and that's is getting communicated to the data acquisition step, which is the next step. So now in the next step, we are going to see that we're doing a lot of data collection. Okay, and we're transmitting information. We're basically establishing a communication between this data sources, and the data acquisition receivers, right? So in simple ways, this is the source of information, right? And this is your receiver, where you are basically receiving those informations, right? So there's a constant communication in between the two, which is established in this step. In the next step, we are going to explore data pre-processing. Now, what does data pre-processing means? It means that you're just converting the data in such a form which is helpful for the business, or in our case, the system to analyze on an efficient basis, right? In this step, what we're doing is we are doing data cleaning. Like obviously, there are certain like all the data which you have in your database is not actually helpful to your inciting or maybe analysis part. So in this case, we do data cleaning and we eliminate all the unreliable or unusable data which is not relevant to the business. So that's what we do over here. In data integration, what we do is we are integrating all those data sets. So as you saw that we are getting the data from various sources, right? After cleaning all these data sources over here in this step, we're going to integrate them and create a master data file, right? So after creating this master data file, we are going to compress this data because obviously, since the data size is very huge, we try to bring that data size down to as much as possible. So the best format in which we try to convert it is through in this step. So over here we do data compression. We're trying to reduce the data size. And in the next step, which is the data storage step, obviously when we have created so much amount of data, we have to store it in a much efficient way, where we talk about the managed part. So till here we were talking about all the ETL process, extracting the data, transforming the data, and loading the data. And but now in this particular step, we are going to talk about how we're going to store, or in other words, we're going to manage the data, right? Because this step is very crucial. This will basically help you define how fast the speed of like efficiency, or yeah, we could say the velocity of big data analytics is happening, right? So coming to this step, storage step, over here we'll, okay, this is a huge explanation, but I'll try to break it down for you. So over here, we what is our aim? We want to store it in a storage infrastructure, like which is more efficient than your own system, right? So these storage infrastructures are like Amazon's cloud-based services, or Microsoft's cloud-based services, which is called Azure Databricks. So now we have to store it over here. But to store it over here, we need to have a management software. What the management software is doing is it's trying to generate data models. What are the data models? They're the small chunks of data which are placed at various sources. These sources are linked to each other. These sources are linked to each other, and through the database management system, we are connecting all these links together, uh, right? To generate memory locations, right? So we're just trying to generate memory locations of where the data sources are located, and then we're going to, get a file system which has all the memory locations. Now all this setup, all this management setup is stored in the soft storage infrastructure, which is a cloud-based service, right? Now, cloud-based service is a very difficult term to understand. So I'll just say a cloud-based service is something just like your own operating system, but having a much advanced, probably RAM. So in our case, it's either a 4 GB, 8 GB, or 16 GB system, and in maximum 32 GB system. But over here, the RAM will be very high. It will be you can choose various type of RAMs, various type of specifications basis your own system. You can choose a Windows-based system, or Linux-based system, or your Macintosh system. So you can just treat this management step as a system which is much more advanced and has a specific management software which is helping you keep up with the speed that is required for the efficient management of the system, right? So that's mostly around the data storage part. And then coming to the last step, which is the data analytics. Now in this step, what I explained, the whole recommendations engine is deployed over here, right? It is doing all types of analysis, like it's doing descriptive analysis. It's trying to understand the data. It's trying to do the predictions, and it's trying to prescribe recommendations, right? So it's giving the various types of users recommendations at the end, and that's the whole big data analytics life cycle. So I've tried to explain it in a much I've tried to break down the whole problem in pieces, and I've tried to explore the whole thing. Uh, so that's mostly about the my part in terms of big data analytics. There are some references which I've shared for recommendation engines. Like if you want to understand more about recommendation engines, there are some papers which will be very helpful to you, to understand what what Amazon is doing these days in terms of its own recommendation engines, how it's analyzing various types of data, and what all algorithms they're doing. You can get into the detailed mathematics of it if you want, obviously. Then, okay, so what was my motivation? If you want to get into this industry and you liked my presentation, and you understood and something in this made you interest, gain some interest around it. So definitely you need to bring it up, and that will pull you in into this field. For me, it was machine learning. I saw that doing various predictions and knowing what the future is. That's what I used to interpret. Knowing what the future is, basically, I just wanted to know what the future is. That's why I came into data science and big data analytics. And this is that one thing that will keep you in data science or big data analytics. Otherwise, you will break. So that's all from my part. Okay, now I'm open to questions from you guys. I
Yes, sir. Thank you, sir. That was a wonderful presentation from your side. So let's start off with the questions. We have a few follow-up questions in the thing. So as a beginner in sense, having basic programming knowledge in Python, how to get kick-started in data science?
okay. Okay. So my recommendation to you is, if you want to kickstart your career in data science, look at what others are doing. There are various free sources like medium.com. You could explore those. You can see what other people are like. You'll find numerous articles on how to kickstart your career into data science. You start with basics like linear regression, logistic regression, some ensemble techniques, and so on and so forth. You start, then you start building. Like obviously, you study and you start applying those things as well. Try to learn as many libraries in Python as you can, because I think if you know Python, you might know certain basics like data structures and all. Try to explore more libraries and try to apply it on the data, live data, create some projects, put it on the GitHub, and that's how you're going to kickstart your career in data science.
Thank you, sir. I hope your question is answered, Vishal. So again, he has asked one more question. What is this item to item model called?
I'm sorry, item to item model.
Hmm.
Okay. So, okay, I have explained it already. Okay. So item to item filtering, like I said earlier on. So if you have similar items like over here, grapes and watermelon are assumed to be similar, and a particular user in your system has already liked these two items, have spoken very highly about these two items. So if a particular user, like maybe user C, is liking this watermelon, so automatically he will get a recommendation of this particular item. Now this was an item basis an item similarity, right? Uh, so this is what we call an item-based collaborative filtering. Obviously, I know that I might have explained it, but you might want to get into the mathematics of it. But those things are linked in the references, and obviously that's out of the scope of this particular session. But yeah, if you want to connect with me on this and you want to know more about it, I will share some particular links that I have, which will help you out in understanding this in a more detailed way. But obviously, you can understand it through the references also. Yeah. So. I think
Yes,
that answers your question.
thank you, sir. So there's one more question. What skills need what skills I need to be an algorithm researcher? Can deep learning be used in data science?
Yeah, we use deep learning all the time.
Okay, thank you, sir. Rhythm has asked, how does data analytics help in business field?
Uh, so, okay. So let's suppose, okay. So let's suppose you're talking about Mars, or maybe Cadbury's. Okay, Cadbury is a chocolate, and chocolate is something we actually all like. So let's talk about chocolates, right? So if we talk about chocolates, if we get into the business part of it, so what do you think does the businessman, like business people in Cadbury's want to do? Like, how do they think they are going to improve the business? They obviously they want to find those areas in India. Let's suppose we're talking about India as a geography, and Cadbury's want to spread their business in India. So what they'll do is they find high affinity areas, geographies. Like suppose in India's case, there are metro areas like Delhi, Kolkata, Mumbai, Bangalore. These are Jaipur. These are places where Hyderabad also. These are places where people have a lot of money and they're willing to spend. Like if you just experimenting and bringing a very new product which is not there in the market already. So these people will spend anyway on those things because they have a lot of money and they want to spend. Uh, a business will analyze certain areas like this and start experimenting over there and then start developing its products according to what response it gets. So now when it's doing this whole process, it's collecting a lot of data, right? So obviously if you want to analyze the data and come out with insights like this, if this region is doing good response, if it's giving a very good response or not, if Mumbai is looking forward for healthy chocolates or non-healthy chocolates, so what is the affinity they want to do this, understand all these things. So you cannot just look at numbers and you cannot derive assumptions out of it. You have to do a lot of apply a lot of data analytics to it, and then only you can derive certain meaningful insights that will be helpful to the business. So I think this answers the question.
Yes, sir. Thank you, sir. So Angela is asked, what other
Mhm.
courses do I take and learn as an electronics and communications engineer and have just started with programming?
Okay. So what type of programming language have you been exposed to? This is my question. No, then only I'll start answering the question.
I request you to answer, Angela.
Okay, you are starting Python. Okay, fine. So, if you have started exploring Python, I would say that you explore a bit around Python and then start exploring a bit around statistics. Uh, Try to understand what are basic statistics. Like in school times, we have studied about mean, mode, median. Uh, uh, so there are certain other things also which you need to study apart from this, and obviously you have to understand how you have to study and apply all these three things using Python. So once you're through with the statistics steps, then you start with machine learning. On medium.com you will find numerous sources of understanding machine learning. So you will get how to, you will be able to, yeah, it's obviously related to AI. Finished. Yeah, that answers the question. So that's how you'll get started into data analytics, and that's how you'll get into data science. Angela, I'm sorry if I have a derail from the question.
Sorry, sir.
Have a derail from the question, or have I answered it?
Yes, sir. You have answered it, of course.
Okay, okay.
Yes. I hope Angela is clear about it. So moving on to the next question. Yes, she's clear about it, sir. Thank you.
Okay.
So Nitin has asked, what is business analytics in data science? What are its feature and exposure other than in big data?
Business analytics is just like you just trying to understand your data. Let's suppose in Delhi area, you are seeing like you have three customers in Delhi area. You have eight customers in Mumbai. We have six customers in Kolkata, right? So that's not a very big chunk of data. You can just open your Excel sheet and see what the data is, and you're just trying to understand which particular region is like spending more on your products. So that is just basic in the business analytics. As you try scale, like if you scale the data to a certain maybe MBs or GBs, then you can use Python for the same business analytics. If you're going to scale it to TBs or something bigger figure, then use big data analytics. So that's analytics for you. As you scale the data, so the just the application source is different. One in first case you are applying in on Excel. When the data is small. In second case, when the data is a little bigger, then you're applying on Python. In the third case, when the data is very huge, you're applying it using big data analytics. So analytics is everywhere. Just the way you are applying it is changing with the application business requirement. I
Yes,
think that
sir.
answers.
Yes, Nitin, I hope your question is answered. So, there's a question from Vineet Sahu.
Okay.
He's belonging from third year electrical and electronics engineering with
Hmm.
placements coming up in a few months' time. How do I manage time and learn about data science effectively?
How much months? 3 months, you said?
A few months, sir. Few months he's mentioned.
Okay.
He's already a third year student, but placements are coming up in few months. How do I manage time and learn about science effectively, data science effectively?
Okay. So on my LinkedIn profile, and mind you, I'm not marketing my profile, but on my LinkedIn profile, I have mentioned a whole learning path on how you can become a data scientist within 4 months. So you can refer to my first slide, PPT, or maybe connect with me on LinkedIn. I'll guide you through that particular slide. Just follow the instructions which I've mentioned through that learning path, and that will help you to become a good, like, it will help you gain a very good data science knowledge in this industry. It will make you it will help you become a data scientist actually. So uh, it will take around 4 months to do that. So just keep a 4 months duration for learning this whole process. And that I think that should answer your question.
Yes, sir. He's mentioned. Thank you. It is clear. So, moving on with the last question as we wrap up with the session. What is
Okay.
the best way to upgrade your problem solving skills in the field of Python?
See, I would say that everything comes with experience. The more you practice on different use cases, the more you explore the data, the more projects you build. Like for me, I'll tell you a bit about my data science journey. So when I was at the final year of my MBA, I started just like you guys. I started learning Python, and I struggle a lot around it. Uh, then when I joined KPMG, that was my first company after finishing my MBA. I tried to apply, like I built a very basic web scraping tool through Python from what all I had learned during my MBA days, and I implemented it over there for them. It automated a lot of things for them, and it helped a lot for the business. So after I did that, I thought that I can do very well in terms of you know data analytic. Like I should get into proper hardcore data science, and then I started exploring data science a bit more. So then I took a professional course, and that's how I reached it. There's this question from Shalini. I'm doing business analytics now in final year. Do I have to learn the same thing for business analytics? All what we have learned on data science. You see, business analytics is just so you can just analyze the data through Excel also, as I mentioned, right? Doing business analytics is just like using common sense. It's nothing more than common sense. Like uh, you can easily do that through your common sense. Uh, in data science, what you have to do is you have to understand how to apply that common sense through coding, right? You have to learn basic statistics for that. Like in terms of statistics, what you do is you do various types of tests. You try to understand what is, like suppose if I'm talking about rainfall, and then there is it's for farmer production. What they're doing is, like, suppose farmers are coming up with crop production. So I if I want to do a statistical test to understand whether the the two events, that, like, suppose rainfall and farmer production are related or not. So I'll use statistics for that, using coding. So you need to learn statistics for that, and you need to learn a bit of coding, And if you have a bit of common sense, then you can start it and get yourself started in business analytics in the data science industry. I think that answers the question, Shalini. Okay,
Yes, sir.
cool.
Yeah.
Cool.
So yes, sir, we have covered all the questions that was asked,
Okay.
and it's time to wrap the session. So
I
yes.
hope it was a learning session for you guys, and I have not bored you at all. I mean, I know the topic is really boring, and I've tried, to break it into smaller pieces that will help you understand. But obviously, if you didn't get a thorough knowledge of it, then obviously you can get in touch with me. And if you have you still have doubts, or you have curiosity around it, I'll be happy to help you. This is my email ID. You can mail me. This is my LinkedIn where you can come and connect with me. This is my website where you can post questions in the chat box. I'll get your questions, and I'll answer it to you as soon as possible. So I think these things would be helpful for everyone.
Thank you. Thank you, sir. Thank you for sharing your thoughts, views, and ideas. The tips that you shared with us was enlightening. Not to forget about your presentation with slides was visually attractive. The way you presented left nothing unnoticed, sir. Thank you again for answering all the questions which made the session much more interesting and engaging. And thank you, dear participants, for actively listening and adding much more sense for today's session. Thank you, sir. Thank you once again. Thank you.
Okay. Thank you, guys. Bye bye. Have a good day and all the best.
Thank you. Thank you, sir.